So I'm going to continue with the Unit 1 lecture by talking about prefixes. Now you've probably had a lot of experience with prefixes, but just as a review, prefixes are used to indicate decimal fractions of various units. So a common prefix that we use is the prefix milli. Now, for example, if we're talking about volume, there are 1,000 milliliters in 1 liter. So what that prefix allows us to do is look at decimal fractions of that unit. So there are 10 to the third milli, whatever unit you want to talk about in that base unit. Another one that we commonly use is kilo. So for example, in 1 kilometer, there are 1,000 meters. So it allows us to have some variety in our measurements by just adding a prefix that changes the quantity. Now here in this table there are a number of different prefixes that I've included. The most common ones are the ones closest to the center though, so milli, centi, deci, kilo, mega, and then as you go down, micro, nano, and pico. In section 1.5 we're going to be talking about uncertainty in measurement. And whenever we're measuring, there is always some uncertainty, and that uncertainty is in the last digit that we report. So for example, if I have a thermometer, as you can see in this diagram, and I have a 25 degrees Celsius mark and a 30 degrees Celsius mark, if I were to estimate that that alcohol line, that red alcohol line, goes up to about 27, that 7 is being estimated. I am uncertain of its accuracy, but I'm going to estimate that it's a 7. Now, whenever we're measuring, you will always have just one digit that is uncertain. So when we're talking about significant figures, the significant figures are all of the digits, including the one that is uncertain. If I were to look at that measurement and say, oh, well, it's 27.5 degrees Celsius, I now have 2 digits of uncertainty, and that is not allowed. You can only have 1 digit of uncertainty, and that is included when I'm counting number of significant figures. So if you look at the value 2.2 versus 2.2405, you can see, and I'll review counting sig figs with you in just one second, that 2.2 is not as certain of a measurement as 2.2405, and we'll learn that that's because 2.2 only has 2 significant figures, while 2.2405 has 5 significant figures. So this is a trick that I use for counting significant figures, and it's extremely helpful once you're familiar with it. Here's a map of the United States, and on the left-hand side, hopefully you know that you have the Pacific Ocean, and on the right-hand side you have the Atlantic Ocean. So how this trick works is if I have a decimal present in my number, Pacific Ocean present, then I'm going to be counting from left to right to count number of significant figures. So if the decimal place is present, count left to right. If the decimal place is absent, which is Atlantic, I'm going to be counting from right to left. Okay? The only rule that you need to be careful about, other than in what direction you're counting, is that you cannot start counting on a 0. So here's an example problem for you. If I give you 0.034, notice that the decimal place is present, so I'm going to be counting from left to right. I have 3 values, 0, 3, and 4, but remember you cannot start counting on a 0, therefore that 0 right there is not significant, and so the 3 and the 4 are the only digits that are, so that value has 2 significant figures. I'm going to have you guys complete the rest of the practice without my help, and we'll review it in class. Alright. Now, it's one thing to talk about significant figures when you're looking at a value. It's a whole nother to include them when you're doing calculations, and you're going to be doing a lot of calculations in this class. So the first rule is for multiplication and division. If you multiply any value or you divide by any value, you determine your final answer based on the fewest number of significant figures. If I'm adding or subtracting, I'm going to base my final answer off of the fewest number of decimal places. And when a calculation involves 2 or more steps, so let's say I'm adding and multiplying, you write answers for intermediate steps. You retain at least one non-significant digit for the intermediate answers so that you don't end up with rounding errors. Now, I like to keep my intermediate values completely in my calculator and I don't round at all. If you want to write them down, and don't worry, we'll revisit this, but if you want to write them down, make sure you include at least one non-significant digit, so go one further out than you expected to. Otherwise, you'll have a lot of errors in your rounding, especially if you're doing a lot of calculations as you go. Alright, so for this example, I'll give you 14.3505 and ask you to add it to 2.65. So before you get started, remember this is an addition problem, and therefore if you're going to be basing your final answer off of the fewest number of decimal places. Well, 14.3505 has 4 decimal places, the 3, the 5, the 0, and the other 5. 2.65 only has 2 decimal places, so my final answer needs only 2 decimal places, and therefore it's 17.00. The next problem, I'm multiplying now, so now it's going to be based on the fewest number of significant figures. 3.29 times 10 to the 4th has 3 significant figures. You ignore the 10 to the 4th with regards to sig figs. So 3.29, 3 significant figures. 0.2501 has 4 significant figures because that first 0 in front of the decimal place is not significant. Therefore, my final answer needs 3 significant figures. So I get 8.23 times 10 to the 3rd. Okay. Here's a last section of Unit 1, and it's dimensional analysis, and I'm going to work through this problem right now. Dimensional analysis involves the conversion of units from one unit to another unit. So in this practice problem, it says a woman has a mass of 115 pounds. What is her mass in grams? And so what I like to do before I get started on a problem is write my given. And so what's given to me is that this woman weighs 115 pounds. Now, I'm being asked to convert this into grams, and so I need the conversion factor from grams into pounds. Now, this is not given to you, so you would need to look this up on the web. And what I found when I looked up the relationship between pounds and grams is that 1 pound equals 453.592 grams. Okay, this is my conversion factor. This is going to allow me to convert between pounds and grams. It tells me the relationship between pounds and grams. And so what I'm going to do is, in order to get rid of pounds, I put the unit pound on bottom. To get into grams, I put the unit grams up top. And then I'm just going to put the conversion factor here. So if you look over here, they're 453.592 grams in every 1 pound. And so what you'll do, since this value is in the numerator, I'm going to multiply 115 times 453.592, and what I get is 52,163.08. Now the first thing you need to do is notice that since my pounds canceled, my units are grams. And the last thing you need to recognize is the fact that since I am multiplying, my final answer should have the fewest number of sig figs that any value, any measurement here has. This measurement has 3 sig figs, therefore my final answer should have 3 sig figs. So my final answer is 52,000. This is going to be my last significant digit. However, since there's a 6, that's going to round up to 2. I can't leave it like this because this would just be 522, which makes no sense. So I need to add 2 zeros to hold the place. They do not count as sig figs because there's no decimal present. Therefore, I count from right to left, so there are only 3 significant figures here. And my units are grams.